Hey there, ladies and gents, Mr. D here, and in this video we're going to be talking about how to reduce/divide exponents and the properties that lie there within. So let's go through and kind of do a quick recap of what we do know about exponents. So if we had two pieces being multiplied together with the same base, we could just simply add their exponents together. If you had an exponent directly on the outside of parentheses, so a power raised to a power, you would multiply those exponents together. If we had something where you had maybe a negative exponent and you wanted to make that negative exponent become positive, it would have to switch its position to the other side of that fraction bar, and in doing so, it becomes positive. So those are the properties that we've kind of discussed thus far. Some other properties that are going to come into play is if you have any base raised to the power of 0, that is always going to be just 1. And then if we're dividing, so I'll do two examples here. If we're dividing exponents that have the same base, what you're doing is finding the difference between these exponents. Now this works best if both exponents are positive. So if you have a scenario where there's negative exponents, you need to kind of flip things around. Go ahead and flip things around first. So what we're going to do is find the difference here. And the reason this works is if I had x to the 5th, that's really 5x's being multiplied together. Down below I'd have x squared, which is 2x's. I have the ability, if I were to cancel things out, I can cancel an x with an x, another x with an x. And I'm left with these 3 x's up top. So I'm left with x to the 3rd power. And then there's nothing down below, so I just put a 1 there. This can also work with exponents in the denominator as well. So if I had x to the 3rd and x to the 7th, if I did that same logic, right, where I wrote it out in expanded form, I'd have 3 x's up top, 7 down below. If I canceled them away, well, all 3 x's from the numerator would be gone. So I just have a 1 up there. And if I got rid of 3 of these 7x's, well, there would only be 4 left over because 7 minus 3 is 4. So again, we're just finding the difference between these exponents. And your base is going to land, whether it's numerator or denominator, wherever the bigger exponent was. So bigger number wins. So we're going to keep that in mind as we go through. You guys know the drill. At any point, if you need to pause and rewind, feel free to do so. If you need to screenshot something, go for it. So here we go. Number 1. We have negative 5, x to the 3rd, y to the 10th, z to the, there is no exponent, so I'm going to throw a 1, over 75, x to the 4th, y to the 7th, and there's no z's. So what I like to do, again, is kind of compartmentalize these things. So I'm going to color code this. What I mean here is numbers interact with other numbers, x's interact with other x's, y's interact with other y's, and z's interact with other z's. So that is to say, whatever happens with this negative 5 and 75, it's kind of siloed off over here. It has no effect on all this other stuff. So let's go through and simplify what we can. If I think of a fraction, negative 5/75, I could reduce that, couldn't I? I can divide both top and bottom by 5. So that would be a negative 1 up top. Then down below, 75 divided by 5 is 15. So all I've done is just reduce a fraction. That's it. Next up for the x's, I've got 3 up top, 4 in the bottom. Well, if I found the difference there, the difference would be 1. So I'm going to have x to the 1st power, and that's going to be in the denominator here, because that's where there were more x's. So I'm going to have x to the 1st power down below. Now if I look at the y's, I have 10 y's in the top, 7 y's in the bottom. If I canceled away a bunch of y's, namely I could cancel away 7, so all 7 from the bottom, but then I'd also have to cancel away 7 from the top, I'd be left with 3 y's left over, and those 3 y's would be in the numerator. Then lastly we have the z. Well, the z doesn't really have a counterpart to interact with, so that just keeps its original value, z to the 1st. So this simplifies down to negative 1 y cubed z all over 15x. You might see this more kind of condensed, written like this. Me personally, when I do these by hand, I prefer to keep things kind of nice and siloed out. For me, it's just easier to follow along. These two pieces, the black ink and red ink, say the exact same thing. All right, let's go to number 2. So number 2, we have to be a little careful because I'm noticing we've got some negative exponents. So anytime I see something with a negative exponent, I want to take that term and kind of scooch it to the other side of that fraction bar. So before I try to do anything, I'm going to make sure every exponent here is positive. So I need to rewrite this with positive exponents. We still have the negative 12, we still have the negative 28. Up top, that x to the third stays put, but then we have x to the second. That was the part that came from the denominator. You'll notice it became positive now because it transferred through that fraction line. This y to the 7th, or negative 7th, is gone because that's going to be down to the bottom. Down to the bottom, we already had the y to the 4th term, but then joining the party now is y to the 7th. So now if I were to kind of think of this, doing my little color code, I've got the plain old number coefficients out front, but now my x's that are interacting, they're no longer one above the other. Right now, they're side by side. Same thing goes for the y's. They're no longer one above the other, they're side by side. Well, if they're side by side, that means I just get to add the exponents together. So first, let's reduce this fraction. Negative 12 over negative 28. Negative over negative, it's going to become positive. These share a factor of 4, so I could divide 4 out of each of those. That gives me 3/7. I've got 3 x's, 2 more x's. That's going to be x to the 5th. Down below, I'd have y to the 11th. That would be my final answer. Now let's say, hypothetically, you're not a huge fan of doing that whole switcheroo, right? Bringing it from the bottom of the fraction up to the top. You could still do subtraction to find the difference of these exponents, but if I did 3 minus negative 2, 3 minus negative 2 is really 3 plus 2, which is just 5, and that's exactly what we had. So you could do that as well. Just make sure you're really paying attention to where that exponent would land, whether it's numerator or denominator. All right, number 3. We have x to the negative 2nd. Y to the 5th, all raised to the negative 2nd power. Now there are 2 paths we can take when we do this. Path 1, and I should mention both paths are going to get us the exact same answer. Path 1, we can distribute in right off the bat. So this would be x to the positive 4th, y to the negative 10th. We can distribute in right off the bat. And then we can rewrite this using only positive exponents. We don't really like negative exponents. So this would be x to the 4th over y to the 10th. Or what we could do is simplify the inside first. And this is what I typically like to do. So if I simplify the inside first, it'd be y to the 5th over x to the 2nd, all raised to the negative 2nd. And then from there, if I have a negative exponent on the outside, that really just means I'm flipping things around, so I'm doing the reciprocal. So that's really x squared over y to the 5th to the positive 2nd. So again, if I flip the reciprocal here, that just makes it from a negative exponent to a positive. And now, this exponent outside can affect all of the exponents inside, again giving us x4 over y10. So there's 2 different ways that we could tackle problems like that. All right, next one, last one. We have 2x squared y all over 9x to the negative 4th y to the 5th times 6x to the negative 3rd y to the 4th all over 10x to the 4th y to the negative 1st. Holy smokes, is that gross. Well, let's get things cleaned up here. Now, I should mention, the fact that we're multiplying 2 fractions, if I really wanted to, I could think of this as one big fraction line because it's all going to be the same as we go through with multiplication. But for some of us, it might be helpful to just kind of focus on one thing at a time. So that's what I'm going to do. One nice thing about these styles of problems is the order in which you do things isn't super important. As long as you're doing everything accurately, the order doesn't always matter. All right, so first I'm seeing a -4, so I'm going to bring that up to the top. Let me rewrite that. I'd have 2x squared, and then we just brought x to the 4th up there, y, and that's y to the 1st power, all over 9y to the 5th. That's going to multiply with 6. This x is going to have to get kicked down, and the y to the -1st is going to come up. So we have 6y to the 4th, and then y to the 1st, all over 10 x to the 4th, and then x to the 3rd. So first thing I did is just kind of rewrote this, getting rid of any negative exponents. So now let's make this pretty. 2/9 can't really reduce, so I know it's going to start off with a 2 and a 9. Next with my x's, I've got x squared, x to the 4th, that would be x to the 6th. Mentally, if you guys wanted to do a mental shortcut, 2 minus -4 would give you that 6. And then we've got our y's. I've got 1y up top, 5 down below. So if I canceled some out, the y would be completely gone from the top, but I'd have 4 y's left down below. So that first fraction is simplified. Second fraction now, 6 over 10 becomes 3/5. Up top I'd have y to the 5th. Down below I would have x to the 7th. So now let's combine these things here. This whole numerator I can kind of multiply together. So I'm going to have 2 times 3, which is 6. So 6x6, y5. 6, x to the 6th, y to the 5th. All over 9 times 5, so 45, x to the 7th, y to the 4th. 45, x7, y4. And now we simplify again. 6 over 45 is a fraction. They share a common factor of 3. So I can reduce them down by a factor of 3. That would be 2/15. I've got 6 x's up top, 7 down below. If I canceled them away with one another, there would be 1 x left over in the bottom. Another way you could do this, 6 minus 7 gives me a -1. So I'd have x to the 1st, but in the bottom because it was -1. With y's, I've got 5 up top, 4 down below. If I cancel some away, reduce it down, I'd have 1y left up top. So 2y to the 1st over 15x to the 1st, or more condensed, like that. All right, that is it. That is all for this target. Between targets 3 and 2, you should have all of the exponent properties down now. So we'll see some more challenging problems as we go. You know the drill, folks. If you have any questions, please let me know. Don't be shy. As always, good luck. Have fun. Be safe. Roll Tide.